Hello students, I am Saili Rathod from ICEM Engineering College. Today I welcome you all in the new video of electrical measurement techniques. This is video number 5 and today we are going to cover the topics of the first unit, that is classification of standards, block diagram of generalized instrumentation system. So before moving ahead with the new topics, we will have an overlook that we have covered up till now in the video lecture series of electrical measurement techniques. In the first lecture, we have started with what is actually the measurement, what is the need of measurement. After that, we have seen the different properties of measuring instruments. That is, in that we have seen static characteristics of instrument and dynamic characteristics of instrument. Okay, so after that, in the previous lecture, we have seen what is actually a standard and what are the different types of standards. That is the classification of standards. The list of that standards we have seen in the previous lecture. Today we will see each and every type of standard in detail. After that, we will see the block diagram of generalized instrumentation system, and we will also study about each and every block of this instrumentation system. So let's start with today's lecture. Here we have seen the standard and its classification in the previous lecture. So what is a standard? Standards are devices that are compared against less accurate devices to verify the performance of the less accurate devices. Okay, so what is meant by a standard? As the word itself says, that it is a standard type of instrument which is used by comparing with other instrument that is to be checked. So by comparing the standard and the device to be checked, we can calibrate the instrument. So the standard it is used generally to calibrate the instrument. Okay, so there are 4 types of standards. First one is international standard, second one is primary standard, then third one is secondary standard, and fourth one is working standards. All are the types of standards. So we will see one by one. Here we will see the international standard. As the name itself says that it is an international standard, means this standard is accepted worldwide and it is defined on the basis of the international agreement. Means where the international standard agencies decide the standards about the measurement systems, there is an international agreement where each and everything is specified in that agreement. So this is the first type of standard. They represent the units of measurement which are closest to the possible accuracy attainable with present day technology and scientific method. Means what does it say? According to the present day technology and scientific method, means the technology that we are using in day to day life, and for this technology whatever the instruments we are using, so related to that or comparing with that, this standard is represented. Okay, so this is the international standard. Then moving ahead, the primary standard. Primary standards are absolute standards of such high accuracy that they can be used as the ultimate reference standards. Means for an example, if we are measuring the temperature, then the basic measurement unit is a primary standard. Means if we are measuring it in degrees Celsius, then the degree Celsius it is having a fixed value over the world. Means 1 degree Celsius is same everywhere in the world. So this is about the primary standard, which is fixed everywhere, or in any laboratory. If you measure the particular temperature, then it will be same in each and every laboratory. Okay, so these standards are maintained by the national these standards are maintained by national standards laboratory in different parts of the world. Means wherever in the world, if we use that standard, it is same for the each laboratory. Then the third standard is the secondary standard. The secondary standards are the basic reference standards used in industrial measurement laboratories. Means whatever the standard for measuring anything, it is used in any industrial measurement laboratories. Means the standard reference for that measuring, it should be same for any industry, any industrial measurement laboratories. The second point is the responsibility of maintenance and calibration of these standards lies with the particular industry involved. What does it say? The responsibility of maintenance. Means this standard which we are using as a secondary standard, the responsibility to maintain this standard and its calibration. So this is the responsibility of the particular industry involved. Means if any chemical industry is using any instrument, then the responsibility to maintain that calibration of that and maintenance of that instrument is of that particular industry. This is about the secondary standard. Then the working standards. The working standards are the major tools of a measuring laboratory. These standards are used to check and calibrate general laboratory instruments for their accuracy and performance. Means the general instruments which are used in the general laboratory, then that instruments are used to check these standards are used to check and calibrate general laboratory instruments. Okay, so wherever there are small instruments used in that laboratory, these uses the working standards to measure their accuracy and performance. All these four standards, it is a very basic concept. Only the minute difference is there about the four standards. Like international, it is a international standard which is same worldwide. The working standard, it is used to check and calibrate the general laboratory instruments. Okay, so next point is the block diagram of generalized instrumentation system. So this diagram shows us the general instrumentation system where we can see different blocks. From this we can see that the input, as this is an instrumentation system, we know that for this instrument we need a quantity to be measured, which is given as the input, and as this is a measurement system, measuring instrument, means it will give something as the output which will represent in any form, in analog form or in digital form. So input is a quantity to be measured and output is the display of that quantity which is measured. Okay, so the basic blocks of this generalized instrumentation system is, first one is primary sensing element, then second is variable conversion element, third one is variable manipulation element, then next one is data transmission element, and fourth one is data presentation or controlling. Okay, so from this flow we can see the quantity to be measured is given to the primary sensing element. Primary sensing element, what does it do? It senses the quantity, means if it is a weight, it will sense the weight of that instrument. Then accordingly it will pass the information to the variable conversion element. Okay, so it is a variable conversion element. It means what? It will convert that physical quantity into a particular signal. Okay, so physical quantity is converted into a particular signal. It may be a electrical signal. Then this data is given to variable manipulation element. It means it will manipulate the data and give the output to the transmission element, data transmission element. So the data transmission element, it will give the output in the form of any signal to the data presentation or controlling block. Okay, so this each and every block we will discuss in detail in the next slide. Here the three main steps that are followed in a instrumentation system. First one is primary sensing element, which senses the input. Second one is variable conversion element, means which converts the data from one form to another form. And third one is data presentation element, which is used to represent the output. So what does the first point says? Primary sensing element, which senses the quantity under measurement. Okay, so the quantity that is to be measured, it is sensed by the primary sensing element. Then second one is variable conversion element, which modifies suitably the output of the primary sensing element. Means the output from the primary sensing element is taken by the variable conversion element, then it modifies into suitable output form. So this is the function of the variable conversion element. And the third one is data presentation element, that renders the indication on a calibrated scale. Means it will show us the output, or it will represent the output on the display element. These are the basic three steps that are followed by the instrumentation system. Now moving ahead, we will see one by one block in detail. The block diagram is shown below. Detailed description of each blocks. Okay, so the detail about each and every block are as follows. First one is primary sensing element. Primary sensing element. The measurement first comes into contact with primary sensing element where the conversion takes place. This is done by a transducer which converts the measured quantity into usable electrical output. The transduction may be from mechanical, electrical, optical to any related form. So the main function of this primary sensing element is to convert the measured quantity into a usable electrical output. So physical quantity is converted into an electrical quantity. This is the first block. Then second one is variable conversion element. The output of the primary sensing element is in the electrical form, suitable for control, recording and display. The signal is suitable for control, recording and the display. So this signal is given to the next block. So before that, we will see the function of this conversion element. For the instrument to perform the desired function, it may be necessary to convert this output to some other suitable for preserving the original information. This is the main function of the variable conversion element. This function is performed by the variable conversion element. A system may require one or more variable conversions suitable to it. So depending upon the instrument, it may use one or more type of variable conversion units. Okay, these are the two blocks. Then the third block is variable manipulation element. From the name itself, we can say that manipulation element means what? The signal gets manipulated here, preserving the original nature of it. Means the signal is manipulated, it is changed in some other form, but preserving the original nature of it. It does not change its original nature. Here we have given one example of an amplifier. Amplifier is what? It converts a small voltage signal into a signal of greater magnitude. This is the main function of the amplifier, means it does not changes the nature of the signal, but still it manipulates the signal. The output is the same voltage but of higher value, acting as a voltage amplifier. This is an example of variable manipulation element. Next point is, here the voltage amplifier acts as a variable manipulation element since it amplifies the voltage. The same point is explained here. Friends, as this is a theoretical concept, so I have tried to cover all the basic points related to this block. You may find it somewhat theoretical and boring, but still all the points are very important. I highlighted some of the important points to remember the basic concept of this block. The next point is, the element that follows the primary sensing element in a measurement system is called a signal conditioning element. The variable conversion element and the variable manipulation element are collectively called as the data conditioning element. Okay, so the data conditioning element means what? It is a combination of two, variable conversion element plus the variable manipulation element, means conversion plus manipulation, both the functions are done where? In the data conditioning element. Okay, so this is about the third function of the third block of this system. The next one is data transmission element. Data transmission means what here actually done, the transmission of data from one another is done by the data transmission element. Okay, from the name itself we can say that the transmission of data is done from one place to another. In case of spacecraft, the control signals are sent from the control stations by using a radio signal. The stage that follows the signal conditioning element and data transmission element is called the intermediate stage. Okay, so this is a intermediate stage in which conditioning is also done and as well as the transmission of that data is also done. This is about the transmission element. The next one is data presentation element. This is the last block of the block diagram. The display or readout devices which display the required information about the measurement forms the data presentation element. Here the information of the measured has to be conveyed for monitoring, control or analysis purpose. Here we have written some examples like ammeter, voltmeter, recorders. All what are this? These are the data presentation element. Some recorders like magnetic tape, TV, equipment, storage type, CRT and printers. All these are also the data presentation element. Okay. So this is all about today's topic, in which we have covered the standards, types of standards, where they are used, and the block diagram of the generalized instrumentation theory. Okay. So this is the end of today's topic. We will see you in the next lecture. Till that, keep studying. Bye bye.